All right, so the last lesson for Unit 5 is going to be on applying everything that we have already used so far. So we're going to be solving log and exponential equations. So solving log and exponential equations. Okay, so we're going to start out with log equations. And just a quick reminder, if we look at forms, so if we have log base b of y, and that's equal to x, if we wanted to switch this into exponential form, our base is b, so this would be, have a base of b, logs are equal to exponents, so x is our exponent, and then that would equal y. So just a quick review of conversions there. So our first example, we're going to take a problem, it's going to be log base 5 of x minus 9, and that's going to be equal to 3. So if we're solving this, we can't do anything to get the x by itself right now. We can't just add the 9 over because it's inside the parentheses. That makes this a part of our log equation. So what we're going to do is we're going to change forms because logs and exponentials are inverses of each other, so there's no way to solve them without doing the opposite. So we're going to take our base of 5, because this is a log base 5. Logs are equal to exponents, so our exponent is 3, and then that's equal to what's left over, which is x minus 9. So we've switched this log equation into exponential form, and now we can solve. 5 to the third power is 125. Set that equal to x minus 9, add 9 over. That'll work for me. Add 9 over, and so I get 134 is equal to x. So that's it. Let's do another example of a similar problem. Let's do a second one. Let's take log base 7 of x plus 3 and set that equal to negative 1. So again, same thing here. We have an x plus 3 in parentheses. We can't do anything with that. So we're going to take 7, change forms here, exponential form, 7, base is 7, to the exponent negative 1. Then we've got x plus 3. So we'll solve that 1 over 7. Remember, a negative exponent changes that to a fraction. And set that equal to x plus 3. When we solve that right there, we're going to subtract 3 from both sides. So we're left with negative 2.8571 is equal to x. All right, so we're going to take a look at another example now. This time it's going to be a little bit different. So if we look at one that has, let's take log base 2 of x plus 8 equal to 7. Now notice that what's different about this problem than the other ones that we've been doing is the x plus 8 is not in parentheses. So when this is in parentheses, it's all one term. Right now it's not. So the log base 2 of x is one term, and we need to get this log, isolate the log. We need to get the log by itself on one side of the equation. So right now, we need to move the 8 over, because we cannot switch forms the way that it is right now. So if we move that 8 over, too much. Once I move that 8 over, I'm going to subtract 8. So I have log base 2 of x is equal to negative 1. Now I can change forms. 2 to the negative first power, because my base is 2, logs are equal to exponents. Set that equal to x, and get 1/2 is equal to x. Because that negative exponent is going to make that a 1/2. Similarly, if I have a problem like this, if I have another example, let's go with 2 log base 5 of x, 4x minus 7. And we want to, again, get that log by itself, but this 2 is not a part of that. So we're going to divide everything by 2. So we have log base 5 of 4x minus 7. Set that equal to 2. Change forms here. So we've got 5 squared is equal to 4x minus 7. So 25 is equal to 4x minus 7. Add the 7 over. And we got what, that 32. And And so x is equal to 8. Now, I don't know why the smartboard's being goofy, but x is equal to 8. There.